In this quick lesson, we are going to talk about adding and subtracting decimals. When adding or subtracting decimals, be sure to line up the decimal points. Then carry out the operation in the way you would add or subtract integers. Why is it important that we line up the decimal points? It's important because addition and subtraction are not powerful operations. When we come across these not so powerful operations, we have to do the work for the operation. When we get to multiplication and division, the operation kind of takes care of it for us. But with addition and subtraction, we have to take care of it, of the operation for it. And also, keep in mind, things that you work with all the time involve decimal points, like money. And you don't want somebody to owe you $5, but then they don't really know where the decimal point goes, so they give you 5 cents. So those are the kinds of things to keep in mind when you're adding and subtracting decimals. So if we have an example, 3 and 62/100ths plus 6 and 57/100ths, we stack them on top of each other in our traditional addition algorithm, making sure that our decimal points line up, and then we add them as we normally would. So 7 plus 2 is 9, 6 plus 5 is 11. The decimal point comes straight down, and then 6 plus 3 is 9, plus the 1 we carried from the 11 is 10. So 10 and 19/100ths is the sum. And I make sure to tell you here so you can get it in your notes, bring the decimal straight down to maintain the place value. If you're working with $3 and $6, you want to make sure you end up with the sum of $3 and $6 and whatever change you've got. So if we were adding 9 plus 3 and 245 thousandths, it would look something like this. Now, it's important because I want you to think about the values of the numbers you're working with. You're working with 9 and 3 and some more. So which of these numbers is larger in value? Sure, 3 and 245 thousandths has a lot more digits, but it's a small number in comparison to 9. 3 and 245 thousandths is kind of like almost 3, right? And 9 is 3 times larger than 3. So 9 is still greater in value than 3 and 245 thousandths. So just keep that in mind when you're setting them up. Even though 9 doesn't have a decimal point that you can see, you can still add it to another decimal number. So when we add it together, remember that that decimal is located right behind the whole number. It's at the end of it. So there's technically always a decimal point there, whether you see it or not. Now, a lot of people like to fill in zeros here. I don't demand that that be done, but it holds the value for you so you can see what you're adding it to. This 5 is being added to 0, so you have 5. 4 plus 0 is 4. 2 plus 0 is 2. The decimal point comes straight down, and then 9 plus 3 is 12. And I say that you can estimate to find the reasonable answer before solving. Well, I said a second ago that 3 and 245 thousandths is kind of close to 3, right? Well, what's 9 plus 3? Well, that's 12. Is this a reasonable answer? 12 and 245 thousandths? Well, yeah, it is. It's close to 12, so it's absolutely appropriate. Here's another example. Negative 5 and 78/100ths plus a negative 18 and 3/10ths. Well, we're working with decimal numbers. They both happen to be negative. This should revert us back to our adding integers rules. Now, these aren't integers. These are rational numbers. But because we're working with two negative numbers, they follow the same rules as our integers do. So if I look and I know I'm doing addition and the signs are the same, add and keep the sign. So what you can think is, well, I can just add 5 and 78/100ths plus 18 and 3/10ths, making sure to keep the place value by lining up those decimals, okay? And then you can fill in a 0 here if you feel like you need to hold that space. Go ahead and add them together. That's 8, 7 plus 3 is 10, so I have to do a little bit of regrouping by carrying. Bring the decimal down. 8 plus 5 is 13, plus 1 is 14. And then you add the 1 and the 1 to get 2. So I have 24 and 8/100ths. What did I forget? Well, I'm adding two negative numbers. Remember, add and keep the sign. Keep the sign, keep the sign. So don't forget that that negative goes there because you're not actually adding positive numbers. You can work with positive numbers. Just remember what you started with. Do not forget the importance of the value of the negative. When we go to subtraction, we can subtract just like we normally do using the subtraction algorithm. But again, like I said earlier, you have to be sure to line up the decimals. So if I had the example 12 and 49/100ths minus 7 and 25/100ths, think about first, what is that about? That's about 12 and a half. And that's about 7 and a quarter even. But if you think, what's about 12 minus 7? Well, that's around 5. So my answer should kind of be hanging around 5, give or take a little bit, because we are working with decimals and parts of those wholes. So I line it up, making sure, and I put the note down here, remember that with subtraction, order matters. Remember, the commutative property is for addition, not subtraction. So we can't change the order. If it says 12 and 49/100ths minus 7 and 25/100ths, it has to go in that order. And correct order goes from left to right, top to bottom. So we have to maintain that. So I lined up my decimal points and I can go ahead and subtract. 9 minus 5 being 4. 4 minus 2 is 2. Decimal points, and I can go ahead and borrow if I want to, but it's just going to be 12 minus 7 anyway, and 12 minus 7 is 5. 5 and 24/100ths. I don't have any signs I needed to worry about, so I should be good. Remember, I thought to myself earlier, my answer should be near 5. Here you go. Perfect. So the next one that we have to work on is 14 minus 7 and 32/100ths. Remember, this is 14. Like $14, not 14 cents, not 14/100ths, not 14,000, it's 14. And this is 7 and 32/100ths, $7.32. So 7 is half of 14. So 14 is definitely larger. Anyway, when we're setting it up in subtraction, we need to make sure that the place values line up. 14, the 4 is, it's a 10 and 4 ones. This is 7 ones. And then we get into our tenths and hundredths. If you choose to do so, you can fill in that decimal point and those zeros so your subtraction works better. In fact, you need to for subtraction, right? So I can't take 2 away from 0 in our traditional algorithm, so I have to go to where I can. The first place I can borrow is with my 4, so I will take 3 away, or excuse me, I will take 1 away, and I will just say that that's now 3. This 0 becomes a 10 because I borrowed a 1, and now I have 10 tenths, but I don't need 10 tenths yet because I need hundredths, so I can take 2 hundredths away. So I have to borrow from that 10, make it a 9, and now I have 10 hundredths. 10 hundredths take away 2 hundredths is 8 hundredths. 9 take away 3 is 6. That's 9 tenths minus 3 tenths. The decimal point comes straight down, and now I have 13 minus 7. 13 minus 7 is 6. So 14 minus 7 and 32/100ths is 6 and 68/100ths, which is close to 7. So it's kind of like 14 minus 7 is about 7. We're close to it, so you should feel pretty good about your answer. So as I touched on earlier, with decimals, we'll have to follow some integer rules. So I just make a note here. Follow the same rules for addition and subtraction of decimals as you do for integers. Again, they're not integers, they're rational numbers. But you do follow the same addition and subtraction rules. Notice here, addition problem. It's negative plus a positive. Signs are different. Find the difference. So this gets a little tricky when you think, find the difference, and then take the sign of the number with the larger absolute value. Well, which number has a larger absolute value? Which number is further from 0 is what that's asking you. Is it 7 and 238, negative 7 and 238 thousandths, or a positive 6 and 9 tenths? Which one's going to be farther from 0? This bad boy right here is going to be farther from 0. So when you find the difference, you're going to say to yourself, and you're thinking, take the sign of the larger number in absolute value, you know your answer is going to be negative. So it's okay to say equals, negative. Now you don't have to worry about that sign again. So take the difference, well that's going to be 7.238 minus, make sure you line up the decimals. That importance does not change. If you need to fill in the zeros on the bottom number, be my guest. Either way, you're subtracting nothing in those places, so it's going to be 8 and 3. I need to borrow from the 1 here to get 12 tenths. 12 tenths minus 9 tenths is 3 tenths. That decimal place comes down. 6 minus 6 is 0. I can put that 0 there. I don't have to. Doesn't change the value. But now it is 338 thousandths. Remember, it's negative. This comes right over here. Negative 338 thousandths. You're going to have to start being comfortable with working with these negative decimals. It's okay. Think about where you might see negative decimals in real life. The stock market sometimes goes negative. It's always in decimal form. If a bank account goes into the red, negative amounts of money, it's not always going to be whole dollar amounts. You've got negative cents there. Negative decimal points, anywhere, really. I mean, if we just brainstorm, you can come up with where you would see negative decimals. So here you go. Another example, 32 and 6 tenths minus a negative 15 and 86 hundredths. Minus a negative. Well, I'm doing subtraction. I know it's subtraction. I rewrite it so that I'm adding the opposite. Look what we have. This is just an addition problem. Fantastic. So when I add, no signs to worry about anymore. This is awesome. So make sure you just line up those decimal points when you go ahead off to the side to add. You can fill in that 0 if you feel the need to. 6 plus 0, 6 plus 8 is 14. Bring that decimal down, and I'm sorry I'm running out of space. 5, 6, 7, that's 8. And 3 plus 1 is 4. 48 and 46 hundredths is my answer. And I'll just go ahead and box that in. I'm not going to write it over here. Remember that when we worked with the number line, when you subtract a negative, you move to the right? We got larger in value here. So that's something to keep in mind. Make that connection. Finally, we just have a few quick examples, and we're going to run through these real quick. 6 and 98 hundredths plus 14 and 27 hundredths. We're going to come over to the side, rewrite them so that they line up. What did I just do here? What? That's very interesting. This is not the same problem, is it? I changed the order of those numbers, and I can do that because of the commutative property of addition. Sometimes I just like the number with more digits to be on top. Feel free to do that. So 7 plus 8 is 15. 9 plus 1 is 10. I just did it again. That's the associative property. I grouped them, right? 9 plus 1 is 10 plus 2 is 12. Bring that decimal point down. 6 and 4 is 10 plus 1 is 11. And that's 21 and 25 hundredths. Brilliant. Okay. Example B is negative 8 and 46 hundredths plus a negative 19 and 2 tenths. Negative plus a negative. Signs are the same. Add and keep the sign. So I can think, well, my answer is going to be negative. There, now I won't forget about it. So I have 8 and 46 hundredths plus 19 and 2 tenths. Add them together. That's a 6. 6, 8 and 9 is 17. 27 and 66 hundredths. That's a negative 27 and 66 hundredths. Don't forget about the negative. Don't forget. Example C, 6 and 72 hundredths minus 4 and 16 hundredths. Can I change the order in subtraction? It's not commutative, so I have to keep it. 6 and 72 hundredths minus 4 in 1600ths. I'm always keeping that decimal lined up. I do need to do some borrowing here. I'm going to do that quickly. 12 minus 6 is 6. 6 minus 1 is 5. Decimal point straight down. 2 and 5600ths is my answer. Moving on, 24 minus 3 and 8/10. I need to write this so that the appropriate spaces line up. This is 2 10s, 4 1s. This is 3 1s. So the 1s need to go on top of each other when you're subtracting. It's very important. Also when you're adding. I can add that decimal and that 0 because I'm going to have to do some borrowing. So I'm going to borrow from the 1s. That's going to be 10/10 minus 8/10 is 2/10. Bring that decimal down. 3 minus 3 is 0 and 2 minus nothing is 2. So 20 and 2/10. No signs to worry about. We're in good shape. That's my answer. 4 and 1600ths minus 9 and 43,000ths. This brings up a very interesting issue. You may want to rewrite this as 9 and 43,000ths minus 4 and 1600ths because you're more comfortable with 9 minus 4 because it seems to work better. But you cannot change the order of a subtraction problem. It is not commutative. But what you can change the order of is an addition problem, which is why when we have this issue, we say we can add the opposite. We're taking a larger number in absolute value away from a smaller number in absolute value. So we can say 4 and 1600ths plus a negative 9 and 43,000ths. Now that this is an addition problem, I can think to myself, signs are different, find the difference, and then take the sign of the larger number in absolute value, which I know is this. Doesn't it make sense that when I take away a larger number, I'm going to end up negative? Exactly. So my answer I already know is negative. I know I need to find the difference. Finding the difference. So I'm going to say now I can change that order to make it work because it's addition, and I can do that with the commutative property. 9.043 minus 4 and 1600ths. That's going to be 3. I have to do some borrowing. 8, that's 10. 9. 14 minus 6 is 8. 9 minus 1 is 8. Decimal point straight down. 8 minus 4 is 4. 4 and 883,000ths, and it's negative. Okay? Think about it. It's like 4 minus 9. 4 minus 9 is about negative 5. Are we at almost negative 5 here? You bet we are. So it's very good work right there. Good job. Now I have negative 123 minus 2 and 5500ths. Negative minus. Integer issue. I'm going to go ahead and add the opposite, so I think that might work out a little bit better for me. Negative 123 plus, this is positive here, but no, I can change it to negative 2 and 5500ths plus a negative, plus the opposite, negative. Add the opposite. Now I'm adding, and signs are the same, so just add and keep the sign. That means my answer will be negative because they're both negative. 123, and I'm just going to say 123 plus 2.55. That's a 5, 5, 5, 2, 1. 125 and 5500ths, and remember that your answer is negative.